So, Fundamentals of Mechatronics and Robotics by me. Oh, right, so in this assignment I am to show that I have the ability to identify, select and apply different mechanisms and drive systems to a given problem to further develop my knowledge on embedded programming and demonstrate I have the ability to apply techniques to produce a unique solution to demonstrate my ability to report and present the outcome of a design task using a set of formal reports and presentations to use my knowledge gained to develop and construct a robotic system to perform a defined task. In this task we will first understand what guidelines and mandatory tasks required to be achieved by the build of the robot. This is important to have a goal in mind when planning a project, as it gives solid direction to what steps are required. The robot must travel at least 60 meters to interact with an object and return as close to the start as possible. When looking at the challenge, I thought the main problem would be identifying whether or not how we will identify the target compared to like a wall, for example, using ultrasonics. So what I thought is how I tackle it. So I thought I'd get a sensor which could detect light or colour, which help differentiate between the target and the wall. So builds. First build based off a lecture session. You can see what it implements there, and it features 3 wheels. 2 of them are controlled by servos with a servo controller, and one of them is a free wheel. From that I implemented same components, all of that, and yeah, so what I did, I put the battery further back, put some things in different places, but roughly very similar, and I used sellotaping as a holding method. So this is my code. If you want to see more of it, have a look at my report, which we're currently seeing. So this code would allow the car to move around using the ultrasonics. However, I do feel that it wouldn't be able to tell the difference between a wall and the target. So based off that practical test, I found that the robot wouldn't move. This could be for 1 or 2 main reasons. The first would be the ultrasonics are broken. The second, the level shifter is broken. It could be any of the components which were broken. However, the speculation I could tell the Arduino and the Pololi were working fine, and the servos were connected and working as I had thought they would. So yeah, I noticed it getting hot. So I think what must happened is I put a few wires in the wrong place. Anyway, so moving on. Yeah, so for my next build, I was looking at. I thought there was something wrong. It was either the ultrasonics which caused it, or it was the level shifter. Now, I thought it could have been either, so that's when I tried changing a few wires around because I thought I got it wrong. Now, what that did, it burnt my Arduino, so I had to get a new one. So for my final build, I had to wait for my Arduino to come so I could test to see what exactly was broken on my robot. Turned out it was the ultrasonics. However, now that I found out that they were broken, I couldn't actually get a replacement for it in time, or did have the funds to do so. So here are components that we use. So the Arduino. Yeah, so it's so this goes through a lot of the components that we used and the specifications of what exactly we're using, which you can read up on in my report. You've got the servo controller there. The ultrasonics, which were the problem child of my, I guess, project assignment. And you see the level shifter. That's what I thought was causing problems, because I thought there's something wrong with it, or it was broken. Battery box, that works fine. And yeah, so this was all in the set which was given out by the university, and basically this was everything which was in it. The all works fine, but I think for a more efficient and more accurate movement, I'd recommend using not using a freewheel, because I believe that can create room for error. Best would be a four-wheel drive, but I think having two freewheels over one would be better, even if those wheels were not so free but couldn't rotate left or right, but they could just go round. Yeah, so basically just a loose wheel breadboard. So yeah, if you want to see more of it, just go to my report. I also have, you've noticed I've had links across here. If you want to go see how I got on in the project, you can go watch on YouTube, which is linked. Now, I had a look at the pricings of it, so if it was successful, had more time, I would have looked into, if it was successful, I was going to look into what application it could be used for, and how it could be rolled out, and the costs of it, and how to make it more efficient and cheaper to manufacture. Anyway, here's my conclusion. If you want to know more about it, or if you want to read more about it, you can go to my report again. But the main takeaway from it is that I was unable to, I guess, solve the main problem I found, because I couldn't get hold of the components. Alright, thanks for watching.